Hi, my name is Derek Jones. So basically this is an instrumentation and measurement quiz. So basically today, after watching the YouTube video, and the YouTube video cover the 7 contents, which is bridge of potentiometer, PMMC, MI, dynamometer, induction, type instrument, measurement of voltage, current, power, energy and power factor, instrument transformer, digital multimeter and wattmeter, measurement phase, time, frequency on oscilloscope, CRO, Q meter and potentiometry recorder, and error analysis. This is the electrical and electronic measurement, but for today we will cover error analysis and the limiting error. So basically everything is unit. It's specific units. For money is rupiah, USD. For rank is meter, kilometer, centimeter and miles. For weight of course is gram, kilogram, ton. So for the error analysis, basically what is error? Error is the difference between measured value and true value, or we call actual value. So for example, the measured value is 2.01 ampere and true value is 2 ampere. So after doing the calculation, the error is 0.01A and is positive because the measured value is greater than the true value. Okay, we look at the example 2. Measured value is 5 volt. True value is 4.98 volt. And then after doing the calculation, the difference which is the error is 0.02 volt, which is a positive, since the measured value is greater than the true value. Okay, we look at the example 3. 5 volt at true value, 4.93 is measured value. So for the calculation, 4.93 will minus 5 volt with negative 0.07 volt. This is a negative error since measured value is less than the true value. This is the rules. Measured value greater than true value, this is positive error. Measured value less than true value, this is the negative error. After this, we are focused to correction factor. So correction factor, as we know, error is measured value minus true value. For the correcting factor is the negative of error, which means invert the error, which means true value will minus measured value instead of measured value minus true value. Okay, so for the correcting factor is the value which we have add subtract from the measured value in order to get the true value or actual value. So for example, when error is greater than 0, which means measured value is greater than true value, obviously because it is the inverse of error, so the correcting factor will less than the 0. Same to the error that less than 0, the correcting factor will greater than 0. And then for this, measured value is 10 ampere, true value is 5 ampere. So for the error is 10 minus 5 equal to 5 ampere, and the correcting factor is inverse of 5A, which is negative 5 ampere. After this, we look at the error static. Error which is independent of time, dynamic error which is independent of time. For the relative static error, RSE, the formula is error divided by true value, which is E over AT. But E we define as measured value minus AT, so the formula is AM minus AT over AT. Basically, the relative static error can determine the quality of instrument. So the lower the percentage, the higher the quality of instrument. So consider 2 ammeters, true value is 2A, error is 1A, and for the B is 1000 ampere and the error is 10 ampere. After the calculation, the percentage of RSE for A is 50%, for percentage of B is 1%. So we can prove that the B instrument has higher quality. For the limiting error, consider an ammeter whose true value is 2 ampere, The range is 0 until 10 ampere. Limiting error is plus minus 1%. Then find the range of operation. So the true value is 2 ampere. The limiting error is plus minus 1%. So the range is 2 minus 1% to 2 plus 1%, which after doing a calculation, which is the 1.98 ampere to 2.02 ampere. Thank you.